All right, so we are going to start going over Unit 1.2, electrons, ions, and isotopes. So the electron cloud, it has the neutral atoms have the same number of electrons as they do protons. So I'd write this at the top of your periodic table. If you don't have it out, please pause this video and make sure you have that on your screen. So electrons equals protons when we have a neutral atom. Electrons are buzzing around the nucleus at very high and fast rates in the electron cloud. Again, things that are underlined and highlighted in different colors should also appear that way on your notes. They are held in place by their attraction to the protons in the nucleus. So because the positive and the negative charges attract to one another.
I'll add Joel saying that it must be true. Notice all of the color-coded pieces. Electrons equal protons in neutral atom. That should be notated on your periodic table if you haven't already. This electron cloud business, we will be depicting atoms as if they are in orbitals that are very singular and static, meaning they're not moving, like circles. But the electron cloud, really an electron kind of moves and grooves generally in the same space, but it doesn't have to be in the same lane. So it's like they're on the expressway or the highway, and they've got 4 lanes to choose from, and the electrons are going to kind of bounce in between like a really fast, like a fast and furious car. And so that's what we mean when we say electron cloud, as opposed to a very traditional orbital, singular route that they would travel on.
All right, so our real estate for our electron cloud is divided into energy levels based on how much energy the electron has. So the further away from the nucleus, the higher its energy state, the more energy it will have. So there are a limited number of amount of room in each energy level. In that first energy level around the nucleus, so where it says E1, only 2 electrons can hang out there. That's as much room as they have possible. So that first energy level will be 2 electrons. Our second energy level can hold 8 electrons, as well as our third energy level can also hold 8 electrons. And that fourth electron, our energy level can hold up to 18 electrons.
So this is what I meant about, like an expressway with these electron clouds. So even within the cloud itself, there are these different lanes in which the electrons can move and groove, and they can bounce up and down between these energy levels. That's a very chemistry heavy topic that should you go on and take chemistry, you'll talk more about that and how they move. But the higher they go, the more energy they have. So that's something we'll talk about in second semester when we talk about like the aurora borealis and northern lights. That all has to do with these energy levels. So the chemistry in the beginning of the year ties into that astronomy at the end of the year. Please pay attention to these numbers, 2, 8, 8, 18, all right? That's as far as we go. There are more energy levels than 4. We are gonna stop and limit ourselves to just 4 energy levels. So 2, 8, 8, 18, please make sure, all right? 2, 8, 8, 18, you've got that highlighted, you've got that color-coded in your notes as we go forward and start looking at valence electrons and what these electrons actually do on these energy levels.
All right, valence electrons. This is super important. So please make sure that you are highlighting this key vocabulary word. Valence electrons are electrons in the outermost energy level or orbital. So if we, that's what is involved in bonding, and that's why it is so important. Atoms are searching for a magic number of 8 valence electrons. They want to have 8 on their outermost shell. 8 valence electrons means that they have stability, which means that they then become a happy atom.
So something that we will be doing, if we haven't done so already, with our periodic tables and yours, is we will be notating individual families that are located, these columns on the periodic table, with the number of valence electrons that they have. And we've probably already said this, but to say it again, the periodic table basically is like a secret decoder chart of lots of information that it provides based on the way it's been designed and arranged. So because of the way it is organized, we can say everybody in group 1 has 1 valence electron, and everybody in group 15 has 5 valence electrons. So we have some interesting little secrets there that are hidden, and once we know those tricks, it's easy to be able to look through the periodic table and to see them, even though they're not explicitly written there, okay? But this magic number of 8 equals stability. Why? Because this last group over here, that's in kind of this reddish pinkish color, they're called the noble gases. And the noble gases are the most stable elements on the periodic table, meaning they are unreactive. They don't tend to interact with other elements because they don't need any electrons from anybody. So we consider them royalty, and as with most royalty, they don't interact with the peasants, and you can consider everybody else on the periodic table to be the peasants. So these valence electrons and this magic number of 8, everybody else in groups 1 and 2, these messy ones down here that we'll talk about later, 3 through 7, all of them, they want to be just like the noble gases, and they want that magic number of 8. So again, color coding and highlighting lots of key information on this slide. As Case says, you may want to notate this slide as being an important one in the slide title as well.
All right, on to ions. Ions are atoms with a charge, so either a positive charge or a negative charge. They have the same number of protons, so it's still considered the same element, but they have a different number of electrons. So ions have to do with electrons. Either more electrons, so then it's going to be more electrons than protons, so those are called anions, or fewer electrons than protons, and those are considered cations. And I like to remember cations as that T, so they're going to have a positive charge, and the anions are going to have a negative charge.
So what we will begin talking about in this unit, and then be the focus of our next unit, is this idea of ions and how they interact. This is why chemicals explode and why they interact and why fireworks, blow up and all that kind of stuff. This is the reason, because we have various ions in nature. And what that means is that they are those unstable elements, those elements that are not noble gases, and they are either in need of more electrons, all right? They need to get some, or they are wanting to get rid of electrons, all right? They want to give away a few. And so it just depends on their numbers, and that's something that we'll go over with you in a little bit more detail in class together. Notice the notation that we have for an ion. We're always going to put the charge of an ion in the upper right-hand corner for that particular element. So you can see Ca, and if you look on your periodic table, you will find that Ca is calcium, and calcium is in group 2, and it has a charge of 2+, or a positive 2. On the other side here, you can see S, which stands for sulfur. And if you find sulfur, it's on the right side of your periodic table. You will see sulfur is in group 16. All right, it's in group 16, and that means that it has a total of 6 valence electrons. And if I want to get to my magic number, all right, and I already have 6, I'm going to gain 2 electrons, right? Electrons are negatively charged, and so I'm going to gain 2. And so sulfur is going to have a 2 negative or a negative 2 charge, okay? We'll go through lots of examples of that in practice in class, so you understand the difference between these an and cat ions. You can see on this slide, we're going to have you have that periodic table pulled up, and we will plop some questions in your Edpuzzle right now, corresponding to similar ones, if not the same, as these two. So why don't you go ahead and find potassium and sulfur on the periodic table, and then you will have a series of questions here to take a look at.
All right, isotopes. So atoms that have atoms of the same element that have a different number of neutrons. So ions have to do with electrons, isotopes have to do with neutrons. It's determined by the number of neutrons an isotope is using, determines the number of neutrons in an isotope using that mass number. So you're going to do some math with this, some simple math. So the number of neutrons is equal to the mass number minus the atomic number, or also that atomic number is related to the same as a proton number. You're going to use isotope notation to write out isotope names, like carbon, written out -12. That's a hyphen and not a minus. Or you can shorten it and use its element symbol of C-12. Remember, that's a hyphen and not a minus.
And you can see that notation. Here's isotope notation over on the right-hand side of the screen. Ms. Case just went over how we write an isotope's name in those two ways, and this is how you write isotope notation. So you put the chemical symbol. Upper left-hand corner indicates the mass number, and that determines what isotope you are looking at. Some isotopes are very stable, some are not so much. And then in the left bottom corner is the atomic number or the number of protons. So an easy way to remember how to find that neutron number for an isotope is to take the mass number in the upper left and subtract it from the atomic number in the bottom left. And 12 minus 6 tells you have 6 neutrons in this isotope of carbon. Right?
And that's a great picture to put into your notes if you do not have that drawn. At least make a copy of that picture and put it in there.
Yes. Notice that the upper right-hand corner is where the charge would be if it was an ion, all right? But you don't see one here because we're talking about a stable isotope in this case. All right? You missed those, don't you? Lastly, I think we're pretty close, almost. We have another couple of practice questions that we're going to put in this Edpuzzle for you. And so it will correspond to what you see on the screen here. So again, make sure that you have the Edpuzzle up. You might want your periodic table. That would be helpful as well to answer these couple of questions.
All right, and then this is your quick review. So this would be a good slide to also be able to reference right away. It gives you some nice quick place to go back to. So we have the number of protons is equal to the atomic number. The number of electrons is equal to the number of protons minus the charge. The charge is equal to the number of protons minus the number of electrons. And our mass number is our protons plus our neutrons. And then we also need to be able to find our number of neutrons, which is mass number minus number of protons. And remember that mass number should always be a whole number. Don't pull it from the periodic table. And then the isotope name is written with that hyphen. So either the full name or its symbol, hyphen, and then the mass number. And then the isotope notation is there to the right with the symbol, then the mass number up top, and the atomic number or the number of protons below it.